this is actually the topic I used to talk about, a few years ago. But I think as the community changes, it's still good to revisit, because to some of you it may be surprising how many things are not, or how many developers are not aware of MySQL or database basics. And that's even kind of maybe trending even kind of in their own direction, right, year after year, right? Humanity progress and not always linear, as you can politely put it. The first thing I want to highlight in this talk is this kind of an interesting thing which we see in a lot of companies, especially kind of larger ones, right? You have people who operate in database, and you have developers who use the database and who often don't quite like the database, right? And I'm not going in this part of the talk to go into details what the conflict is, but maybe start with a very important point to begin with, right? Is what, hey, you know what? Really, the database is that like a shared responsibility, right? With developers and operations people, and just trying to point to one another and say, oh, that is only ops have to fix it, or developers just have to do their job and it's going to be wonderful. It's not going to work. And yes, we also can know like guys like Amazon, they like to use and abuse the shared responsibility keywords, right? And use that to cover but with the shared responsibility. But no, it is actually important. With that being said, we'll talk about some of recommendations for developers, right? And for developers which are using an application which happen to use MySQL, but which are not in love with their database, right? Maybe even kind of slightly or more than slightly hated. So the first thing I think which is important is to figure out if that's really a MySQL. Right. Now that is that's indeed is a question which came for years and years, right? I remember probably like 15 years ago, right? I remember coming to customers and they say, "Oh, our website is down again. Let's look at our MySQL again. What's going on there?" I say, "Why do you even think that's MySQL?" Oh, because it's always MySQL. And then it turned out that was like a Facebook API which was down at that point, right? And had nothing to do with MySQL at all, but their initial reaction was to blame the database, of course, right? And then to figure out, right? Now, this is the graph of services, right? From the Karoot. That is another project I am involved with, and I became involved exactly because that is one of the things that does pretty well. With the magic of eBPF, it is able to track all those kind of relationships, right? And really tell, hey, you know what? This component is talking to this, and that, and this is the latencies. Because you know what? What developers tell you they're doing and where their software is talking to may not be what it actually is doing. Right? You want to trust and verify, or better, mistrust and verify. Now, the other thing I think is important is to learn the database basics on very, very high level, right? And it's very interesting how many developers, again, the modern ones, want to operate database while treating this as a completely black box. I don't really know what is going on, and just throw queries at it and get wonderful results. And you know what? That is not going to work well with the large and complicated applications, especially, right? And these are the basics we're talking about. Well, if you look at the query, you want to understand the basic execution of the query, right? And this is their kind of, you can see the dated diagram, because the query cache was murdered in the recent versions, right? But we have wonderful solutions like preset and proxy SQL, which maybe even make it better. You also want to understand how query is executed, and MySQL has a fantastic database. It's a way to look at it, explain you can just run explain, right, if you are, like a command line terminal guy, all right, or you can use tools like MySQL Workbench, which have the query visualization. The other thing which you can look at the queries, especially if you have access to the tools like Percona's PMM or Percona Monitoring Management, you can answer some key basic queries, basic questions about your queries, which I think could be this. First is you can see what queries are closing the load on your server, right? Then the question typically goes to say, well, why are those queries causing the load? Are they doing a lot of IO? Are they crunching for lots of rows, right? Is there maybe kind of some, temporary tables involved, right, which we can help you to see. And then, and that's frankly, I would say that it's something we have work to do, right, like a better visualization and some other things we can do. But you can also see what you can do about them, by having some, access to the table structure, information about table sizes, explains, and so on and so forth. The next thing, well, before I tell that, let me ask you, how many of you guys ever used AI advice for database operations? Anyone?
Why?
What? Well,
We tried.
we tried, and then I'm hearing that we miserably failed. Right? Is that how you got?
Sometimes. Works sometimes, but not.
Yeah. Well, I think it is kind of very, very interesting, right? And to me, what I see with AI tools often is saying, hey, I will get this, they're very bold, but very gray-haired database engineer, well, very experienced, right? Because that's the time of experience, as we all know, right? Goes and asks, ChatGPT a question, say, that doesn't make sense, right? But you know what? If you are a really developer, right, and if you are really looking at, you know nothing about databases, right, then actually you would be surprised how good those models can be in giving you some ideas, right? And this is, well, you guys know, like a DeepSeek is overage, right? And I asked him, some MySQL questions. He actually gave me like some 7 different steps, which are all kind of good, but I just wanted to highlight, some of them it gives. And again, you can say, oh, that's so freaking obvious for you. But if you're a developer who just, completed 2 weeks coding bootcamp, right, then, well, that is not big of a sure. Of course, what is important in this case, right, is, same as at Google. If you just say, oh, fantastic, ChatGPT, DeepSeek, whatever, give me this advice, let me start kind of going copying and pasting, well, that is not a good idea, right? You still need kind of human in the loop to understand if that's actually safe, but that can be a fantastic part of your process. The next thing, I think it's good to understand how queries are executed. Again, it's very obvious for us, right? We all can understand, hey guys, well, you know what? MySQL is kind of single-threaded for most query execution. When are you guys fixing that, by the way?
The single-threaded execution?
Yeah.
It depends.
Use HTTP.
I thought you were going to say like Heatwave.
Is it?
Okay. Yes, but
we are waiting a patch from you.
Huh?
We are waiting a patch from you.
Oh, we're waiting a patch. Okay, now look at that. Excuse, right? Yes. Did you check with your marketing people what you are allowed to respond like that? Would you agree to accept a patch from us?
I asked
you part of their execution?
I asked DeepSeek what they can ask.
You will ask. Okay. But anyway, like that is an important question to understand, right? Because the CPUs those days are so freaking wide, right? Like we can get like 100+ cores on a big thing. The fact what problem is this database like MySQL is limited to a single query is a problem, right? Some databases, well, like Postgres can use parallel query execution for PostgreSQL queries, but they are limited to a single node. And then, of course, there are, Vitess, TidyB, right, which can, take a queries and execute that on the multiple nodes. And that's really, changes a lot, right? Because somebody says, oh, I have this MySQL cluster, group application, right, or whatever, of a 10 nodes, means I shovel a heavy query to that, and then what? Everything is freaking idle. Why is that? Oh, there is only like one server running one thread on one core. Well, may not be the case with database technologies, and you need to understand that to understand how complicated workloads you can put on this spot. Indexes. Well, indexes both are must and both are expensive. Right? These are kind of, again, a very typical thing. How do you see the database schema designed by newbie? It's one of two things. A, you either have a tables with only primary key. B, you have a tables with, like a shitload of indexes where every possible combination of columns is indexes. None of those work, right? Because maintaining indexes is expensive, right? And you need to make sure you understand when you need the indexes and why, right? And that typically means both a process of adding the indexes and also removing the indexes which are not more applicable as your application, your workload tends to change. Then there is a capacity plan. What I mean by that is, look, in a lot of cases, just assuming I am developer and they are ops. I write my stuff, right, and they figure out how to scale. Well, and that may not work, right, as is fair, especially with limiting of your, if you need an application which is going to crunch, I don't know, say 100 million rows, right, well, that's probably not going to fly as a good real-time query of MySQL. It may very well work with ClickHouse, right? So you really want to make sure you understand what scale you're designing with, right? And also think about measurements more than promises. Well, have you guys seen, Dmitry? Is Dmitry here? Oh no, he ran away. He doesn't hold it here with bullshit. Well, maybe he knew I was going to quote him. How many queries per second was Dmitry able to get out of MySQL? Right? It's well over 1 million. Right? But if I'm a developer says, oh, wow, look at that. MySQL can handle 2 million queries, right? And I only need, my application uses like 5 queries per something, right? That means I can do, shitload of that something. Well, maybe not because you're doing different queries, right? And there is a lot of that stuff, think about, for example, somebody say like, oh, Google Spanner can do gazillion updates a second. Okay, try that as a single row updates. Everybody containing on that single row. That may not be the case. And there are a lot of those kind of really nuances, right? And remember, marketing people, are not paid to be truthful. Right? So they are typically going to show the product from most advantageous thing, right? Or say their things they can get away with, right? So make sure you are looking at some of your experiments, right? And your measurements rather than, just promises. If you look at the scaling, I think it's also good to understand what we generally have those two approaches, right, to scaling, the vertical scaling and horizontal scaling, right, which different technologies support to different extents. The MySQL, again, can scale vertically for many concurrent queries pretty well. Again, complicated queries, not so much because of single query limitations. If you look at horizontal scaling, well, again, like you may be able to get some, scaling the read load, but if you want to scale the write load, you probably need some other solution for sharding. Another thing to mention is what there is a difference between scalable and efficient, right? In reality, it's kind of interesting, right? If you look at the most efficient thing, and I think you can even get some database research for it and say, hey, you know what? We have this like a single threaded operation. No database log, no nothing, right? And that kind of is a very, very efficient way to do things. Once you go now say, oh, I want concurrency. Oh, now I want the distributed systems, right? Well, thing becomes much more scalable overall, right? But they, at the same time, tend to lose in efficiency because of that added complexity. And again, how much? It depends on the engineering. Of course, you can create a crappy and slow kind of single threaded system, right? Well, but I think it's important to understand what with that distributions have comes some complexity, and that means it's good to choose architecture based on what your scalability needs are, because simple and less scalable approaches actually may be more effective for you, right, and easier to maintain. Another thing, and that goes often with our question about the marketing, right? Often developers, especially, they mix kind of an idea of terms of a throughput versus latency, right? So if I tell you, hey, you know what? This system can handle 10,000 queries or 100,000 queries a second, right? Does it mean it's fast to respond? Well, many developers will assume yes, it is, because shitload of queries a second. But in reality, it's maybe, well, it requires 100,000 connections to do that, right? Because every query is just, sleep one, right? As a stupid example. Well, and it's slow, right? Because of that, right? And I think that is a very important to understand what the response times you're getting and the throughput are really kind of the different measures, right? And again, as we do the marketing realities and so on and so forth. That is another thing which I've often seen developers kind of missing, is understanding the limitations of a speed of light, right? And the fact have some, expectations. Oh, you know what? I want a synchronous replication between US and China, sub 1 millisecond. Okay, guys, you know what? If you figure out how to do it, you can probably get some, very big Nobel Prize or whatever it is. There are some other things to highlight, such as connections to the database are expensive. Many queries are expensive, right? Also doing the tests on the realistic network, right? Because many people, run test things on a laptop for a local connection, and where the latency is not realistically low. And also this, right? What you can think about the law of the database gravity, right? Is what a shitty application can bring down any database, right? Way too much. You see their developers are saying, hey, guys, it is your problem. I just have my application. You guys have to figure out. Well, you know what? You cannot. If the application is really bad, no perfect.
Or a single change in a single query because someone makes a rollout.
Yeah.
Take down a huge thing just because of one query that breaks everything.
Absolutely. Yes. The single query may take things, go to shit. Absolutely. Scale matters. You want to make sure what you are testing with the database of appropriate size. Again, many developers, let's say, why don't I play with a toy database on my laptop and then push that in a production, and then you exactly have that query which just does not scale. You also want to understand the difference between memory and disk, right? And yes, SSDs are fast, right? You may read about it and say, oh my gosh, the modern SSDs can do 10 gigabytes per second. Mind-blowing, especially for us who came from like a spinning drives, right? But remember, the latency is still a lot higher than the latency to memory, especially if you think MySQL and InnoDB would always have to access 16 kilobyte blocks, very large, right, from what it sees as a disk, versus it can essentially hit a memory on a cache line size, right, which is much faster. Newer is not always faster, as many of us found out with MySQL 8. Right, and you probably still have bruises from that. But that is generally true, right? Because as engineers make decisions, there are some benefits to those changes and some drawbacks. I remember we also had like a situation probably now more than a decade ago when a new and wonderful generation of Intel CPUs, right, which was actually slower than a previous generation, even though it has good marketing number of gigahertz, right, they had. Also, the upgrades. Developers often hate database upgrades. That is not our fucking problem, right? So they want you guys to figure it out. But you know what? In many cases, that is like once again shared responsibilities, right? And the management needs to make sure to allocate developers' time to do that, which they frankly, bluntly refuse to do in many cases until the database they have is not supported anymore, right? And then the security team kind of say, well, we can't run this anymore, right? I mean, well, look, that can be good business. Your corner has been doing the extended MySQL support, right? Post end of life, MySQL 5.7 support, and that was wonderful, right? But again, that is not a good practice, right? The good practice is upgrade in time. Character sets. That is also something kind of a very foreign, and that kind of habit kind of gradually goes away. It's kind of, hey, just Unicode and, forget about it. But we still have to deal with that, right? And I think it's very interesting is what it's paying to change in the wrong character set can also cause a data loss, right? Some interesting thing here also, they can be substantially different in terms of performance, right? This is kind of MySQL 5.7 and 8. And I think that is very interesting there. MySQL 8 actually both they filed it to UTF-8, right, and made it much more performance, right? Which I know, like in many, 5.7 to 8 benchmarks, right, that kind of difference is low. Another little hint is to not leave database transactions open, right? People often do like, oh, you know what, I do some connect, start transaction, do something, and then go and query whatever API uses data. And it's like OpenAI API, right? And then keep my transaction open. Well, not a good idea, right? That's kind of really is the database. ORM, that is another thing, right? I mean, developers often love it. Ops people often hate it, right? Well, in reality is I think it's going to be used. My preach to developer of, hey guys, you know what? You are responsible for your query. If you come to me and say, well, I don't know what to do, ORM generated this query, please make it run it. Well, you know what? You cannot make database to run the query. It's unable to run properly, unable to optimize. You're not going to go and change the database query. So be ready to manually override your ORM, right? If it produces a query with database kind of stuff, right? Because the queries your application produces is your responsibility as a developer. Right? Again, maybe you have, some query rewrite tools on a database, but actually it's typically rather fragile and not a very good practice. You also probably want to understand the optimal concurrence, right? I think that is a very interesting thing, right? Like there is, linear scalability, this kind of Adam's law, right? You say, hey, gradually scalability scales, but there is also this interest in like Gunter's universal scalability law, which is what applies to the database the most, right? And what that tells you is what actually, if you look about how much throughput, how much work a database can handle, there is actually this like an optimal concurrency. And you don't want the database to go beyond that. How do you do that? Well, for example, you can use ProxySQL and say, hey, I'm not going to allow more than, whatever, like 50, 100 connections to my database. Just do that queuing on a proxy level. And you can do that. And queuing is not bad, right? Because you know what? The queuing closer to the client is more efficient and cheaper, right? Compared to, let's say, waiting on some database logs inside the database. So that is where I think it's a good idea to use their connection pooling that which comes to with a lot of benefit. Okay. I'll skip that. Distributed systems. The distributed systems, they are quite complicated, right? And I mean like some real distributed systems, right? Not something like, oh, I just have a bunch of replica and all the nodes are the same kind of, right? But really say, hey, think about like a v-test, IDB, some other things, right? They do provide a better availability, but they also have a lot more failure scenarios, right? Which you need to think through and test, right? So I would encourage to understand that complexity, understand that there is more effort in testing involved, and also understand how the application performs in different kind of failure scenarios. Because again, if it's kind of a single node, it's kind of very simple. It's either work or it doesn't. In terms of distributed systems, like when well, I can read, like I cannot write, right? Or, like there is a lot of that kind of some reads work, some don't, right? A lot of failure scenarios which you need to be thinking about. The next one is their automation, or also like
I think you're running one slide behind.
Oh, am I? Yes. Thank you. Yeah. I was looking at that.
Is that a database problem or
Yeah, no. That is the human interface problem. No, and not from this side, from that side. You should have told me. What the fuck is that? Yes. You know what? That is what people in management do, right? Okay. Well, anyway, other thing is their automation, right? We all want to automate a lot of database operations, and automation is absolutely essential. But also, it can be really destroying database scale if a database automation goes bad, right? And I think this is kind of interesting, right? Like I would say that if you think about the testing, your automation is perhaps where you want most testing to be done. In many cases, though, right, it's just, well, we had our kind of, DBA implemented some of, like a script, nobody kind of knows, nobody tests it. Well, that is a really problem waiting to happen, and that's going to be very expensive to recover. Well, security, that is also something what you need to be mindful about. And that's, again, like once about shared responsibilities. So many developers I know say, well, you know what? I don't want to care about security. It's kind of, like not interested. I just want to develop my stuff. But you know what? If you are having the poor application design and implementation practices, well, it's very hard for their operations guys to solve all that problem. And again, that your application may be possible, but if somebody in ops will say, hey, I open their access to a database wide, well, then it's going to be a problem. I have, 2 minutes left? 1 minute?
Yeah, no, 2 or 3 minutes.
2 minutes left. Okay. So, anything important you would ask? That's always like a very good, would add. That's always a very good learning opportunity.
Yeah, so I think all in all, I think we see we have a lack of knowledge.
Yeah.
And I think the more severe thing, lack of testing. So I see for 25 years, I see code where people don't test what queries they actually generate or execute.
Yes, that is a very, very good point. Yes.
Local SSDs and SSD on EBS do not have the same.
Yes, I think that is a very good point, right? I think SSDs have become, I think the difference between, your slowest and fastest SSDs is probably more than between spinning drives and the SSDs at this point.
In the cloud, the SSDs are over the network, so they get.
Yes, of course, yeah. Good point. Okay.
I just had a point that I think a lot of management push down to developers these days. You take the full stack yourself. So you don't just develop, you develop and everything all the way down, you manage that as well. And that sounds like, well, a managed service. It's all for free. You don't have to do anything with it. But reality of managing anything except small systems, you actually need to be aware of the whole stack. And that requires more knowledge all the way down. And to handle that at scale is really hard.
Yes, and I totally agree with you, right? And I think that's we see in many cases also that overpromise, if you will, of the managed service providers, right? We can say, hey, it's kind of fully managed, but it's also shared responsibility, right? And maybe in many cases you need to know what questions to ask, right? And if you're not asking these questions, well, it's hard to help. Okay. Yeah, last question, I think, Craig will be Andrew here once again.
Never.
Is it still worth it to educate developers? No.
Let's say?
Is it worth it to educate developers? No. Yes.
Of course. I mean, look, there is no other choice, right? Like in this case. And I think from my standpoint, look, I mean, there is this maybe idea, it's addiction kind of to simplicity and easy, right? And I think there is this eternal conflict because on one extent, we do want to make things easy. Right, we want to make databases easy, right? Wherever it is, programming easy, right? But at the same time, we also want to understand, to educate people what there is inherent complexity to that problem, right? It's just going to go away, right? Okay, the last one.
You have to set your developers up for success, otherwise they are sure to fail.
Yeah, but I think that's a management thing, not
No. You, the database specialist, have set them up for success of the database, or they will fail.
Okay,
Sorry.
cool. Well, with that, also, and I added this slide just, like here a few minutes ago, because bunch of people asked me like, oh, Peter, what are you climbing next? I thought you were kind of doing some of these groups, right? Well, and indeed I do. I kind of turning my hobby in a little, side project, right, called Geeks Go Peaks, and we are organizing various, fun tours, not only climbing. So yeah, if you ever want to go and see something, how Peter can make you suffer, then you can go and check it out.